Hi, I'm Shavin James joining with you with the Electro Vibe channel from a new video that'll allow you to do a lot of stuff. So, I'm here with how to work, like teaching you how to work with servos. I think you know servo motors. You can see them on some proper hardwares in actually building, like in building industry, and there might be servo motors in some your toys as well, and like in robots as well. Actually, the robots using servos a lot. So in this video I'm gonna take you around how to use servos. Actually, I'm gonna teach you with the Wokwi Simulator. It's like the second part of the Wokwi Simulator tutorial. So we'll move on with today's proceedings. So today we are gonna create a simple project with servos. Actually not a simple one, but with Wokwi Simulator. So like simply you can go to Wokwi. I'll search here Wokwi, then go to the Wokwi, and I can see my account because I have signed in before. If you don't know how to create an account and how to get to use with Wokwi, first watch my past video about the Wokwi tutorial, and yeah, that might be helpful if you are new with Wokwi. Then you can look at this video and learn how to work with servo motors. So if you watch my past video, let's move on with the Wokwi Simulator. So here I have my base project of the servo motor. Before explaining it, I'll teach you how to set up the basic stuff for this thing. So I'll go to my Wokwi, and then I'll open a new project like this, then ESP32 here, MicroPython here, and remove this code over here, and then I have this plain ESP32. Then I have to get a servo motor, just simply search servo, then I can see this servo and I can get it. So this is how you should wire it up. So this first one go, you can see it as well, it's GND. That's one benefit of the Wokwi Simulator. And then the other one goes to V plus, means the power output. I'll go with the, so I think you can see how I manage the cables using this Wokwi Simulator. And yeah, so then PWM goes to GPIO pin. So there's more explanation about what is GPIO pins and GPO and GPI pins are in my past video. You can watch it and learn them as well. So back with this thing. So I'm gonna use GPIO 13 because I used it with the other projects as well. You can use any GPIO pins. Make sure it's a GPIO before connecting. Other than that, you may cause a big problem when coding and stuff. So this is how you should set up the hardware. I'm not gonna code this here and make this video much longer. I'll go here, and this is the base code which I used first. So what this thing does is just importing stuff as simple, and then it refines the servo. And here you can see this thing called frec. That means the servos use frequencies to calibrate. I mean the movement. It uses frequencies. That's why we have named it as PWM other than in or out. PWM means pulse with module. So it's use pulse with module action. And so we have some functions defined over here. This is for setting up the angles, and this is for This code helps you to move custom angles, but there's a problem. I'll come to that in later. So here then the custom code, and then we'll run the code and see what the problem that I'm talking about. So we can see it's going. I have set it to go 90 degrees. Now you can see the problem. It goes more than 90 degrees and returns more than 0 degrees and goes more than 90 degrees. So it didn't go to it like position, the position that I need. So to fix that, I talked with my mentor and come up with this. So this is the first. So if you go on with this code, you can see I have defined the servo's frequency differently. That's not affecting much. So then I have the set angle function, but different. Here you can see min duty, max duty is duty U16. So what I have done here is using a map angle to duty U16 range. So that means there's a duty cycle in this servos. I'm using its duty cycle to calibrate with the angles. So here then I have the sweep function, actually same as the custom function, which allows you to set an angle that you need. So in duty cycle there's a bit tricky part. So each and every servo's duty cycle is not the same. You have to calibrate it before using it. So I run this code different times with different values. You have to do little bit of experiments and get the right duty cycle of your servo. So then I have this sweep function here. I have set 90 degrees for here as well. I'll run the code and now you can see the difference. So it's starting from the exact 0 degrees and going to, let's see, yep, exact 90 degrees. So here we'll stop the simulation and we'll put give me a number. Okay, 125 degrees. 125 degrees. Okay. So it went to 0 degrees to reset the servo's angle, and then it's going down. We'll see until what? Okay, that's kind of 125 degrees. So then I did some like, now you can see we can calibrate this servo and do a lot of things. You can make moving robots and a lot of stuff, and that's actually my future goal of this project. Before going to that, we'll see what are the other things I have done. So in here, as a bonus activity, I have done 2 things. So the first thing is I'm using a push button here to control the servo. So I have set a custom angle over here, as you see. So this part is same instead of this button adding part. So if you watch my past video, you can know how to add a button and how to wire it up. Actually, simple things like wiring up is also teach in my past video. You can watch it and learn them. I'm not gonna take much time explaining them as well. So in here I have used those button, a variable for the button, and actually in the past video I also talked about how to use a push button as well. So actually we'll go on this one as well. So there's a problem with this. When we are using the servo and the push button in this simulator, it uses more processing power and it doesn't look working properly. So if I push this push button, the servo should go 90 degrees, and when I press it again, it should come to 0 degrees. So to make sure the button status, I have put a print state as well, the print thing as well, but it stopped serial printing in when I press this push button. That means that there's a bit of lag in this speed. Wokwi, actually this might work like this, not like I have tested in on my hardware. It worked properly on that hardware. That means the code is fine. The problem is with the Wokwi, with that processing powers and things. You can use this code with your hardware. So then we have the random movements code. Actually this code is like generating some random angles. So we have used random module here. You can see I have import random. This part is same as the other one. Then in while true I have use a variable that goes to random dot randint 0 to 180. That means it's gonna get random values in between 0 and 180. Then I'm setting the angle to that, and yeah, that's how it works. Oh, wait a minute, we don't need this sweep parts also. Actually, you can test it on your own. Does it work without the sweep part or with the sweep part? Okay, I'll run the code, and now you can see the servo is making some random angles. So if you need to know what are that random angles, you can simply add a print state over here. I'll print. So we need to print the random angle. And I restart the code, and here it's 20, 48, 120 by 168, 50, 60, 79, 59, 19, 166, 166, 116, 110, 49, 139, 121. Like there are a lot of numbers going. So that's how it goes through the random angles. And my future goal is to make a robot using those multiple servos that can do random movements, or like picking up something and dropping it in a certain place, like that. That's my future goal actually. And if you need to see that video in soon, make sure you subscribe to my Electro channel and hit the bell notification to get the notification when I upload a video right on the spot. And make sure you like my videos, and see you guys in the next video. Until then, goodbye.